Good morning, everybody, or afternoon rather. What am I saying? Morning. Good morning. Welcome to this seminar being organised by the Agricultural Economics and Farm Survey Department in Teagasc. And my name is Kevin Hanrahan. I'm the head of programme in rural economy, and I'm joined by colleagues from across the Agricultural Economics and Farm Surveys Department and by Teagasc Director, Professor Frank O'Mara. And my role today is to just monitor your questions, distribute them to the seminar participants, and to give you just a running order who you're going to be listening to for the next hour or so, and who have the opportunity to ask questions of after that. The director of Teagasc, Frank O'Mara, will give us a brief introductory comments at the start of the seminar. Then Trevor Donnellan, head of the Agricultural Economics and Farm Survey Department, will talk about the new CAP proposals, what's in them, what they might mean across the different dimensions of sustainability. A new member of staff in Teagasc's Rural Economy Programme is Sofia Tisocco, and she will talk about a work we've been doing on fertiliser use in Irish farms. Following Sofia, Marie Merlo, who is a postdoc working with us here in Agricultural Economics and Farm Surveys Department, will talk about a new indicator in this year's report, which is on the quantity of protein produced by Irish farmers across different dimensions. Cathal Buckley, my colleague from AgriCon, will then provide the main results from this year's Farm Sustainability Report. And then after that, that's going to take us about an hour. We'll have half an hour of questions and answers. So with that, I'll pass over to our director, Professor Frank O'Mara. Frank, over to you.
Thank you, Kevin, and good afternoon, everybody, and a big welcome. And just to make you aware, we are recording this webinar, so if you have any difficulty with that, I suppose your option is to leave and maybe look at the recording, which will be on our website later. So look, today we're launching a very important report, which is the National Farm Survey Sustainability Report. And sustainability is a topic that generates a lot of talk and debate, in particular in the area of agriculture. And it's really important to underpin that discussion and debate with reliable and representative data, as we have in this report. And the strength of this report, I think, is that it uses a representative set of farms that are in the National Farm Survey, so they're representative of Irish agriculture. And secondly, the strength of it is that there's a huge amount of data collected in the survey by trained recorders in a very thorough fashion. So that gives a huge degree of reliability to the information that you're going to hear today. And for that, we depend on the tremendous cooperation of the 900 farmers or so who participate in the National Farm Survey. And I'd like to thank them, and also the team of National Farm Survey recorders who collect the farm data, and also the processing team who do the number crunching in the background. So the report that we have today looks at sustainability in its broadest sense, both economic, social, environment, and indeed innovation. And very often when people think of sustainability, they think that means the environment and so on. But, you know, for us, sustainability is that broader definition. And we see the pillars of economic and social sustainability and innovation of being of equal importance to environmental sustainability. The Sustainability Report, it has now been published for 10 years. And again, that's another huge strength to this report, because we can now look at the time series of data and show where progress is being made or indeed is not being made. In terms of today's webinar, and look, as I said, this report has been published for a number of years now, but we're always trying to improve on it and bring new information to it. So today's webinar will have a specific focus on fertiliser use, and we have a lot of detailed data on fertiliser use, on fertiliser prices and the usage of lime. And during the webinar today, we'll do a short demonstration of a fertiliser dashboard that has been built and which was released last week. Also, along with the sustainability report that we are publishing now today, we're also launching another dashboard, a sustainability dashboard, which will allow you or anybody else to interrogate the data, and hopefully will allow you to get more access or more use from the data that's available, making up this report. And the last thing I wanted to call out, again, as Kevin has flagged, is we've added a new variable to the report this year. and that's the protein contribution to the human diet that the various farm systems make. And to me, that's a very important and interesting addition, and I'm really looking forward to the outline of that and to seeing the data that are presented. So look, I think overall we should have a very interesting webinar with some excellent and interesting presentations, and then a good chance for you to ask the people involved and ask your questions. So I'm looking forward to a good discussion during towards the end of the webinar. So with that, I'll hand back and now thank you all for attending today, and hope that you enjoy the webinar.
Okay, I'll take over now, and my name is Trevor Donnellan, and I'm going to make the first presentation of the afternoon. Before I start, I'd like to point to the Q&A function, which is at the bottom of the screen, and I'd invite you to put in your questions at any point, and we'll take those then at the end of the presentation session in around an hour's time. So I'm going to talk about two things in the presentation this afternoon. I'm going to talk about some of the developments that the director has highlighted and why we think they're important. And I'm also going to talk about the new CAP reform proposals produced by the European Commission, and maybe reflect a little bit on some of the changes that are involved there and what they might imply for the pursuit of sustainability in the agriculture sector. So effectively, what we're doing is trying to improve, as the director said, our coverage in our sustainability report. And there's probably three key areas there. We're deepening our environmental data coverage. We're broadening our social sustainability indicators to include a nutrition dimension. On that first point there, I should have mentioned that we have a much more detailed focus now on fertilizers in its own dedicated dashboard. And in the final point there, point 3, we have improved the overall communication and accessibility of the sustainability data we're producing in its broadest sense, with a more general dashboard about the sustainability of Irish agriculture, which, as you'll see in a while now, has over a decade's worth of data in it. So it's telling the story basically of what has happened in agriculture from a sustainability point of view over the last 10 years or so. We're hoping that this is going to strengthen the policy relevance of the National Farm Survey data set. We also think it's important because it points the way for where the EU Farm Sustainability Data Network, and Ireland is part of that. Our National Farm Survey is part of that survey, which exists right across the EU member states. And we think what we've done here in terms of some of the developments in terms of data collection and visualization points to what should happen elsewhere in Europe as well. As was mentioned, and as we will see in a bit more detail in a while, we've got a much more detailed interrogation of the fertilizer data that's contained within the National Farm Survey and the Sustainability Report. So it talks about the usage of fertilizer and lime. So we have information on quantities used, in which systems they're used, the types of fertilizers that are used in terms of NP and K, whether it's straight or in compound form, and of course also the usage of lime, which is increasingly important from the point of view of adjusting soil pH and giving crops better access to the nutrients in the soil. We've also detailed on protected urea and low emission slurry spreading, the extent of the take-up of these technologies, as well as long-term series on nutrient use efficiency and nitrogen balances. And for good measure, we've also included some price data, and that's been particularly of interest, I suppose, given what has happened in the last few years in terms of fertilizer prices in that market. So overall, we think this part of what we're doing is going to improve our capacity to monitor developments in fertilizer and lime use and associated technologies in Ireland. We also had a mention there of this new protein variable that's been produced, and Marie will talk in more detail about that in a few minutes. But we're basically assessing the animal-based and plant-based protein sources in Irish agriculture, and we're examining the protein provision that the various animal-based and plant-based sources produce. And in so doing, we're also making allowance for the fact that there is protein in animal diets. So as you will see in a while, Marie will present data in gross and in net terms to reflect that. How did we manage to do this? Well, a lot of it is based off number crunching associated with the National Farm Survey's agricultural production and feed use data. So we think this will provide a useful metric in terms of food system nutritional sustainability, and it complements ultimately the existing indicators that we've already produced in the report. And finally, we'll see in a while from my colleague Sofia Tisocco that we've pushed forward quite considerably in terms of the accessibility of our long-term series of metrics relating to the economic, environmental, social, and innovation aspects of Irish agriculture. So moving from a static report, which will still exist, into a more useful, we hope, interactive Power BI-based dashboard that will allow people more easily explore the data over time and across systems and by indicator. So we think this will improve the accessibility and transparency of the messages around sustainability, and we feel that will be of great use to policymakers, advisors, researchers, and the broader public. So we're hoping that this is something that can contribute to evidence-based decision-making in this area. I want to turn now briefly and mention the CAP reform proposals, which were issued by the European Commission in the summer of this year. So this is the next CAP reform, the one which will potentially run from 2028 to 2034. It surprised some people, I guess, in the sense that it has led to more significant proposals for change than some people might have expected. There were two dimensions to it: the overall EU budget and proposals around that, and also then within that, specific proposals for the common agricultural policy. And one of the big changes, I guess, is that it's now proposed that there would be a national regional partnership fund, which would be something that the Common Agricultural Policies funds would become a part of. So the idea, to some extent, you could argue, borrows a little bit from the notion of the CAP strategic plans, which have been in place for the current CAP. And what we would see under these proposals is that for the entirety of the budgetary spending of EU funds, member states would be invited to produce a national regional partnership plan, which would be effectively a plan for how all of their EU budgetary resources would be expended. The EU budget next time around potentially will be a lot larger than in the past, a €2 trillion budget, in fact. But what has raised concern, I guess, to date so far is that the Common Agricultural Policy component is just under 300 billion, and that is going to be smaller than would have been the case in the past. So there's some concern that agriculture's budget is now going to be reduced, and that could potentially weaken funding to deliver sustainability outcomes. Second point is with respect to co-financing. There's much more emphasis on co-financing. Co-financing is where member states themselves throw money into the pot in addition to the money that's available from the EU budget itself. So the increased emphasis on co-financing could have some challenges associated with it as well, in the sense, especially if co-financing rates are higher in the future, then some measures or some objectives may seem less attractive from individual member states' perspective, because they may feel that they're contributing more to actually their achievement than they would have had to do in the past. And in countries where public funds are limited, then the idea that you may have to co-finance to a greater degree some of the initiatives could be seen as unattractive. So that raises questions, I suppose, in terms of the extent to which environmental and climate-related interventions would be funded into the future, which could create disparities in terms of the sustainability ambition across the EU member states. Final point then is in relation to the concept of good agricultural and environmental conditions. That term has been around for the best part of 20 years, if I remember well. And the proposals would see that replaced by a notion of farm stewardship. And that concept of farm stewardship and farmers' care for the environment is not particularly well defined at this point. And there's some concern that that could lead to some differences across the member states in terms of how that term is actually interpreted and applied in terms of what farmers are expected to do. So there's some concern that this will lead to some erosion in the common EU standards as a result of that. So the concern here ultimately is that the environmental conditionality as defined under farm stewardship will take on more of a national level flavour. There might be more national discretion, and there's some view out there that this could weaken the coherence of the overall sustainability concept across the EU. So in summary, we've pushed forward with 3 significant innovations around our sustainability reporting in terms of a fertiliser dashboard, which we'll see in a moment, a protein provision metric, which we'll see in a little while, and a sustainability dashboard, which we'll see towards the end. And then in terms of the proposed reform to the EU budget, there are some significant changes there that might lead us to be more concerned about the availability of resources for agriculture in general and for the pursuit of sustainability objectives in particular. So with that, I will conclude and I will pass back to Kevin, I think, maybe to introduce the next presentation.
Thanks, Trevor. That was really informative about what's ahead of us and on the work that the Agricon department are doing in terms of developing indicators that we'll hear about now, when we'll be joined by Sofia Tisocco, who's a technologist working with us in the Agriculture, Economics and Farm Surveys department. And Sofia is going to talk about this work we've been doing on visualizing data, and in particular visualizing data on fertiliser use by Irish farmers. Over to you, Sofia.
Okay. Thank you very much, Kevin, for the introduction. So good afternoon, everyone. My name is Sofia. I'm a technologist working at the Economics and Farm Survey department under the Measure project, which was funded by the Department of Agriculture. And today I'll be talking about the National Farm Survey Fertiliser Use Dashboard. So as a bit of background, fertiliser use plays a critical role in Irish agriculture by maintaining soil fertility, supporting high grassland and crop productivity, and ensuring national food security. From a policy point of view, fertiliser use is closely linked to many European and national frameworks, such as the Farm to Fork Strategy, the EU Nitrates and Water Framework Directive, and the CAP sustainability objectives. It also directly influences Ireland's progress towards reducing greenhouse gas and ammonia emissions from agriculture. Furthermore, over the past few years, there has been rising concerns about increased fertilizer price volatility, such as the 2022 spike linked to an energy crisis. There has been also increased environmental pressures on reducing nutrient losses to the environment and improving nutrient use efficiency. And also there has been concerns around farm viability and how to cope with increased fertilizer costs while producing outputs and compliance with current regulation. All of the above highlight the need to monitor fertilizer use trends and promote sustainable nutrient management, which was the main motivation to build the Fertiliser Use Dashboard. So the data utilized to build this dashboard is sourced from the National Farm Survey from a period of 2005 to 2024. As my colleague highlighted before, the National Farm Survey is built on a representative sample of Irish farms, and it is produced annually to fulfill Ireland's obligation to provide data on farm incomes and costs to the European Commission through the Farm Accountancy Data Network. But over the past few years, and with the transition to the Farm Sustainability Data Network, there has been an increased appreciation of collecting data on the environmental aspects of Irish agriculture, such as the fertilizer quantities used by type, by farm typology, the fertilizer costs and prices, which are the main foundation of this dashboard. The results from the fertilizer use from the National Farm Survey were validated by comparing them with the national sales published by the Department of Agriculture, which I'll come back to in a few slides. So the purpose of presenting this data in a dashboard format is to provide an interactive exploration of fertilizer use and prices by farm type over the years. The main features that the fertilizer use dashboard includes are the fertilizer and land use trends by farm system, so mainly 4 types of farms: dairy, cattle, sheep, and tillage. By nitrate zone, which are zones A, B, and C. At a regional level, which is the NAT3 region and divides the country into 7 different regions. And finally, by soil use potential, which are mainly 4 types of soil uses. The dashboard also contains data on the fertilizer types and prices, such as the NP and K index, as well as the percentage of NP and K applied by main fertilizer type. The dashboard provides transparent and accessible data in a user-friendly interface that will be useful for diverse stakeholders. For instance, it will help in policy support and how to monitor progress on nutrient use efficiency, as well as compliance with many climate and water quality targets. From an advisory point of view, it will help advisors to benchmark farm systems and inform precise nutrient management. And finally, from a research perspective, it will help to quantify fertilizer use changes due to changes in policy, farm management, as well as external market conditions. So before we go into a live demonstration of the Power BI itself, I'd just like to highlight some of the few insights you'll find inside this dashboard. For instance, when you click on the link to access the Power BI, you will be directed into this cover page, and the buttons here on the left will guide you throughout the document. And I'll show that in a second in the live demonstration. Also inside the dashboard, you will find this button, which if you click on it, you will download the data, which is the Excel file that contains all the fertilizer use data, which is in the whole dashboard. You will find this button in many pages throughout the dashboard, so you'll be able to easily find it and access the data. So one of the few insights that is inside the dashboard, and I mentioned it before, is the validation of the NFS fertilizer use data with the Department of Agriculture's data. And in the graph here, we can see the comparison between the national fertilizer sales published by the Department of Agriculture and the NFS fertilizer application data. And we can see that the lines closely track together, and this serves as a robust validation of NFS data. Some differences may occur due to the carryover of farm stocks and the slightly different reporting period from both data sources. Another insight you'll find inside the dashboard is the fertilizer used by farm system. And in the 3 graphs here, we have the nitrogen, phosphorus, and potassium applied on a per hectare basis by year and farm system. And the slicers you see here in the top will allow you to change the graph automatically. I'll show that in the live demonstration. But this serves as an example, as for instance, if we see on the graph on the left, which shows the nitrogen applied per hectare, how different the nitrogen rates are by farm systems and how they have been changing throughout the years. Another insight you'll find inside the dashboard is the fertilizer price. And here, taking nitrogen as an example on the graph on the left, we can see the fertilizer price per kilogram of nitrogen for 3 main types of fertilizers: CAN, urea, and N compound. And we can see, for instance, in this spike, which is at the year 2022, and is linked to the well-known energy crisis. And in the graph on the right, we can see the fertilizer price index for the same N fertilizers, taking the year 2020 as a baseline. And we can again clearly see the spike in 2022 linked to that same crisis. And then inside the dashboard, you will also find the different fertilizer types applied. And for instance, taking again nitrogen as an example, we can see on the graph on the left, the percentage of N applied by main fertilizer type. So we divided the N fertilizer types into 6 main categories, which are straight N applied through CAN, urea, protected urea, and other types of straight N, as well as N applied through not protected and protected compounds. And we can see, for instance, that over the past few years, there has been an increase in the percentage of N applied through protected N sources, such as protected urea, which is denoted as the orange line in this graph. And if you're more interested in knowing more about the protected sources or other N fertilizer types, you'll be able to also find a graph like the one on the right, which divides the N fertilizers into protected and not protected compound types. And we can see we can clearly see that the light blue bar, which represents the protected N sources, have been increasing throughout the last few years. This data is available per crop type, so you'll be able to switch from grassland to cereals to other crop types such as root crops. So before we move into the live demonstration, I'd just like to wrap up the presentation and say that fertilizer use is a critical policy and farm management issue in Ireland. And this dashboard provides 20 years of robust evidence coming from the National Farm Survey. Fertilizer trends reflect both changes in agricultural and environmental policies, as well as external market conditions that may affect the price of fertilizer and ultimately the fertilizer use. The dashboard is now open for the public, and we are open on receiving feedback on further enhancements or any follow-up queries. So thank you for listening, and I'll just stop sharing my presentation and move on to share my Power BI. Okay. So yeah, you should now be able to see the cover page of the Power BI. As I mentioned before, when you click on the Power BI link, you will be directed to this cover page. So as I mentioned before, these buttons over here will lead you throughout the document. So there's many ways of browsing the dashboard. You can click on the buttons here on the left. You can use the arrows here on the bottom to move one page forward and backward. Or you can click on the middle here and all the page names will appear, and you'll be able to scroll down and see whichever section is of your interest. So if we go into the About, you will find more information about the National Farm Survey and dashboard, and you'll be able to access the reports by clicking on this, and the reports are located in the Teagasc website. And as I mentioned, if you click on the link here, you'll be able to download the Excel file containing the data. Yeah, and this button will be present in many pages, so you'll be able to easily find it. And if we click on the bottom here on the corner left bottom, so we'll be directed back into the cover page. So as I mentioned in the presentation, the fertilizer use dashboard contains information per farm system, nitrate zone, region, and land use potential. And it also contains data on fertilizer types and prices, as well as lime use. So if I click on here on the farm system bottom, the data available per farm system is on the population and fertilizer use, but also there's data available such as the N2P and N2K ratios by farm system, as well as the total N, P, and K use, as well as the population and fertilizer use by organic and stocking rate band. So if I click on fertilizer use by farm system, you should be able to see the graphs I showed in the presentation just a few minutes ago. So the slicers over here will allow you to change the graph. And for instance, the results now are showing per crop type grassland, but you can change it to be cereals and the graph will automatically change. So you can see one crop type at the time, whereas you can compare different farm systems in the same graph. For instance, now all the farm systems are showing up, but I can select these to be only, for instance, dairy. And if you want to compare multiple farms at the time, then you have to press Control and click on another farm system, and you'll be able to select more than one. In terms of the year range, you can change the year to be a different year as long as there are between 2005 and 2024. And then if you want to look at the graph a bit bigger, then you need to click on the bottom here in the top right of each graph. And if you click on it, then you'll be able to see the graph in full page mode. So back to the report, and then again the data with the button to download the data. So we go back to the cover page, and then the information available by nitrate zone, region, land use potential, and land use potential based on population and fertilizer use. And if I click on fertilizer use by nitrate zone, then you will see that the design is the same as farm system, and whereas you can see one crop at the time and switch. And then you'll be able to compare one or multiple zones at the time. And then the data available on fertilizer type and price. So we have data on nitrogen, phosphorus, and potassium. And there's a lot of information, but if we can click on fertilizer and fertilizer by type. So this is, again, the graph I showed as an example a few minutes before. And then for nitrogen, there is a bit more data available. And then if we move on, you'll see the fertilizer price of nitrogen, and then the information repeats, but using phosphorus fertilizers and so on. So you can take your time to look at this. And finally, the information available of lime. So we have lime use by farm system, organic stocking rate, land use potential, region, and nitrate zone. And say if I click on lime use by farm system, then the data available is percentage of farms using lime by farm system, as well as the lime applied. And the same is for the other variables. So back to cover page. So you can take your time to get familiar with the dashboard and with the data available inside it. And if you have any queries or feedback on the dashboard, then you can contact us using the details on the last page, and we'll be happy to follow up. Yeah, that's all for me. Thank you very much.
Thank you, Sofia. That was yeah, lots of interesting stuff for people to get their hands into, and I think this is a great example of how the work we're doing across Teagasc and in the Agri-Econ and Farm Service Department, using digital technologies to sort of empower people to look more closely at the data that we publish and adding new data to those that we disseminate. And it's that new dimension of data that we're going to turn to next, where we're having a presentation by Dr. Marie Merlo, who is a research officer working on the AgriAdapt project. So over to you, Marie.
Thank you, Kevin. I will share my presentation now. So yeah. So good afternoon, everyone. My name is Marie Merlo, and I'm part of the Agricultural Economics and Farm Service Department. And today I'm going to walk you through two nutrition-based indicators that we have developed this year using the National Farm Survey and to complement the yearly sustainability report. So first, why associate nutrition to sustainability? If you look at this sustainability framework that the sustainability report is built on, you see the four dimensions that were mentioned before, so economic, environment, social, and innovation. But the main function of the agricultural sector is to produce food. So there is a need to introduce nutrition into that framework. Nutrition is part of Sustainable Development Goal from the UN, goal number 2, which is to end hunger, achieve food security, and improved nutrition, and promote sustainable agriculture. Food security is defined as when all people at all times have physical and economic access to sufficient, safe, and nutritious food that meets their dietary needs and food preferences for an active and healthy life. So food provision and nutrition in general relates to human health and well-being and can be considered a social sustainability indicators, which is how it is presented in this year's edition of the Sustainability Report. So in that nutritional framework, why do we focus on protein in particular? So protein is important in itself, and when we talk about agriculture in Ireland. So protein is a macronutrient composed of amino acids, and of those amino acids, 9 are considered essential, which means they cannot be stored by the body and they have to be assimilated regularly through the diet. So unlike, for example, fat or carbohydrates, protein cannot be stored by the human body. Protein is necessary for growth and development of the body, for body maintenance and repair and replacement of worn out or damaged tissues, to produce metabolic and digestive enzymes, and they are an essential constituent of certain hormones. So proteins have those specific characteristics. They're essential to several critical bodily function, and they cannot be stored by the body, which means they have to be assimilated through the diet. Protein is also at the center of several policy frameworks in the European Union and in Ireland, and protein production is a strategic sector. So in particular, Ireland is self-sufficient in animal-based protein, but suffers from a large deficit in plant-based proteins. And this structure can also be seen at the European level. So there's a strategic component to protein production, especially applicable in Ireland and to the Irish agricultural sector, which means it's important to know where we're at, what the production systems look like today in terms of protein production, and how this protein production is able to feed the population, which is one of the main goals of the agricultural sector. Before I go more into the indicators that we have developed for this year's sustainability report, I'm just going to go through one piece of definition very quickly, but it's the concept of digestible protein, which also relates to how we measure protein production in general. So protein production is particularly important to measure comprehensively because its quality changes depending on the food source it is assimilated through. So eating 100 grams of protein from meat or eating 100 grams of protein from protein crops will not have the same nutritional effect. The digestible indispensable amino acid score, shortened DIAS, is the measure recommended by the FAO to correct protein yield for this quality component that changes across protein sources. This score represents the share of amino acid left for the body to use after digestion is complete, and it is calculated for each of the 9 essential amino acids, and the lowest score is used to represent the quality of the protein source. Why is it important? Because this score varies a lot depending on the protein source we consider. So for example, animal-based proteins show a DIAS of 100%, which means that all the amino acids ingested throughout animal-based protein are used by the body for the bodily functions I've mentioned before after digestion is complete. For plant-based protein, DIAS is between 35 and 90%, which means that not all of the amino acid ingested through those proteins are eventually used by the body after digestion. So what we've done for the 2 indicators that I'm going to present now is we took the protein that was produced or used in Ireland, and we corrected for that digestibility component to really get a clear picture of what is produced in terms of quantity, quality, and how does it relate to this goal of feeding the population. So the first indicator that I'll present is the gross human digestible protein provision. So how it is built, the first step is to calculate the dry matter and carcass contents of crops and meat products respectively. This is done using the National Farm Survey, and correct the dry matter and carcass contents for protein content and digestibility using the DIAS. So the digestible component is included in the indicator. And we allocate the human edible output of farms to the protein requirements of a representative individual to compute how many people can have their requirements met by Irish farms in 1 year. So the characteristics of that representative individuals in terms of weight, calorie, and protein requirements were taken from HAC and FAO guideline. And this metric basically represents how many people can have their protein requirement met by Irish farms in one given year. That's the gross human digestible protein provision. And the second indicator is the net human digestible protein provision. So in that case, we include the human edible input that are used throughout the production process. So it's not only the protein that is produced, but it's also the protein that is used as animal feed during the production process. So the first step is to distinguish human edible from non-edible feed input used on farms, which is particularly relevant for ruminant system, for example, that use a lot of non-edible feed, but also some human edible feedstuff. We subtract human edible protein input from human edible protein output found previously for each farm in terms of digestible protein. So again, all output and inputs are corrected for this digestibility component to also include this quality metric. And this net production is then again allocated to the protein requirement of a representative individual to compute how many people can have their requirements met by Irish farms in 1 year in net terms. So we end up with those two indicators, and we are able to derive number of individuals whose protein requirements are met by hectare, by farm. So I'll go now through some results that we've derived this year that will also be in the sustainability report. The first one, so results for 2024, what we can see is that in terms of gross human digestible protein provision, specialist dairying and specialist tillage farms produce the most. They're able to, so 1 hectare dedicated to one of those two farm systems are able to feed the most people. Behind lies specialist cattle and specialist sheep farm. The same can be observed for net human digestible protein provision. So specialist dairying and specialist tillage come on top, followed behind by specialist sheep and specialist cattle. Sorry. The gap between dairy farms and tillage farms is smaller when we consider net human digestible protein provision, because tillage farm use a lot less human edible feed input than dairy farms. The difference as well between tillage and dairy farms on one side and sheep and cattle farms on the other side could be attributed to the fact that tillage and dairy farms tend to be more intensive, so the production per hectare might also be more in general compared to sheep and cattle farms. The second set of results would be the 3 years rolling average between 2017 and 2024. So we observe for gross human digestible protein provision, again, tillage and dairy farms are on top, followed behind by cattle and sheep farms. And the production is relatively stable. There has been a decrease between 2021, 2023 and 2022, 2024. So in the recent year, there has been a slight decrease, especially pronounced for tillage and dairy farms. The same patterns can be seen for net human digestible protein provision, so more or less stable, with a recent decrease in the number of individuals who can have their protein requirement fed by 1 hectare of 1 hectare dedicated to the 4 farm systems we are looking at here. There still is this narrow gap for tillage and dairy farms in the net human digestible protein provision compared to the gross human digestible protein provision, because we take into account this input component as well and not just output. This set of results presents the protein provision by economic distribution. So it's quite interesting here to look at the difference between bottom, middle, and top farms in terms of gross margin, and how they how the distribution of protein provision works with those three, with this distinction. So there's big gap for livestock farms in general between the top performing farms economically and the middle and bottom farms. This gap is not really observed, or at least not as sharply, for tillage farms. And this is also observed for net human digestible protein provision. So a large gap for livestock farms between the top performing farms and the middle and bottom farms that is not observed for tillage farms. The next set of results would then be the results per farm. So we see here the same kind of pattern in terms of performance of the systems comparatively. So dairy and tillage farms are able to meet the requirements of more individuals than cattle and sheep farms in terms of protein. So on average, across all systems, one farm is able to meet the requirement of 674 people in gross term and 596 people in net term. This ranges from 124 individuals for sheep farm in gross term to 1,315 individuals in gross term for dairy farms, and then in net terms it ranges from 99 individuals for sheep farms to 1,096 individuals for dairy farms. And finally, last set of results would be the aggregated results by system. So we take the number of farms in the entire country, so we don't segregate by farm or by hectare anymore. We do by sector. So the dairy sector, for example, is able to meet the requirement, protein requirement of 19.8 million individuals in gross term and 16.5 million individual in net terms. This is the top performing system. And then we have cattle and tillage farm and sheep farms on aggregate. And last number, the entire Irish agricultural system is able to meet the protein requirement of 35 million people in gross term and of 30 million people in net term, which is well above the Irish population. So the Irish agricultural sector is not only protein provider to its national population, but also globally. So to conclude, protein production is a strategic item for the agricultural sector in Ireland and the EU, and protein provision relates to social sustainability and can be calculated using the National Farm Survey. Dairy and tillage farms perform the best in terms of gross and net digestible protein provision per hectare and per farm. And the main Irish land-based farm systems can meet the protein requirements of about 36 million individuals in gross term and 30 million individuals in net terms, which means if both feed inputs and food outputs are considered. So this really shows the role of the agricultural sector of the Irish agricultural sector as a protein provider and the strategic importance of the sector in terms of nutrition and in a broader sense in terms of sustainability. So thank you very much for your attention, and I'll give the floor back to Kevin.
Thank you, Mary. Thank you very much. That was, again, just more insights based on good data and good science from Marie's PhD work, but also using the data in the National Farm Survey, and in addition to the set of indicators that we have published each year for quite a while now. Cathal is now going to talk to us about the core parts of the sustainability report that we've been reporting over a number of years. So over to you, Cathal.
Thanks, Kevin. Okay, so launch straight into it. So by way of structure, I'm going to go to some background, theoretical framework, methodology, results, and offer some conclusions at the end. So this is our 10th iteration, our 10th report we published in the Agricultural Economics and Farm Surveys Department. The first one dates back as far as 2013. The first author at that stage was former colleague Tia Hennessy, now of UCC, a member of the Teagasc Authority. 2015 was led by John Lynch, former colleague, and since 2018 we've basically published on an annual basis, starting with 2017. We've published annually up to this year. The indicator set has developed, and the data set that needed to be collected has also developed. It's been quite a dynamic process. What do I mean by that? Well, when we finish the results for 1 year, they don't always remain finished, because if an emission factor changes, we have to go back cast those results down to the previous years to account of that change in scientific knowledge. So it's not a static process, forward or backward. We have added a new indicators down to that period, and we saw a new one today in terms of the nutrition. We've also launched a new data visualization portal today for this sustainability data. That is the link to the portal. So to coin a phrase, a lot done, more to do. We're not claiming to be finished. There's a lot more stuff we'd like to do. We have some data restrictions, which I won't get into now, but there is a copy of there's a link to the full set of sustainability reports since the first one. In terms of the framework, look, I always like to conceptualize this like a three-legged stool where you have the economic, environmental, and social legs of the stool, and you have innovation as kind of a buttress that stabilizes the system. And if any one of those dimensions or legs is weak and falls over, then the whole system falls over. So no one dimension is more important than the other when it comes to sustainability. We talk about sustainability. Just a little bit about the sample in 2014. We're reporting across the main land-based systems, dairy, cattle, sheep, and tillage. Over 840 farms is a sample in 2024, representing 86,000 farms nationally based on size and system. Just draw attention to a couple of things in the data. Dairy and sheep tillage farms have significantly larger farms, and especially in case of dairying is growing annually. Even though they're called specialist sheep and tillage, they have significant cattle enterprises. This is important when it comes to explaining emissions profile down the line. Also, dairying has a significant, like what we're calling cattle livestock units, but the majority of those relates to replacement animals. And finally, then the dairy farms tend to be a lot heavier stocked in terms of stocking rate than the cattle and dry stock and tillage farms. In terms of the presentation of the results, if you see a chart like this, it's a box plot where the box in the middle is the interquartile range, 25th and 75th percentile, with the 50th is the median, and the tails are the 10th and the 90th percentile. When you see a graphic like this, it's divided the data by top, middle, and bottom by economic performance based on gross margin. You see a graph like this, it's comparing across systems. Dairy will always be blue, cattle will be red, sheep will be purple, and tillage will be green. And this is a new graphic. We've done this before, but this is coming from the sustainability dashboard, where we're presenting the time series across an annual and a 3-year rolling average. Why do we do the 3-year rolling average? Because you can get, and we'll get into it in a while, we can get positive and negative price and weather shocks in a given year. So we're trying to minimize the noise to see what is the actual long-term trend of some of these indicators. Okay, so starting with the economic leg of the stool, this is what you'll see when you click into the sustainability dashboard for economics. Gross margin and gross output per hectare, returns to labour in terms of unpaid family labour and family farm income per hectare, and finally market orientation and viability, how much of the output comes from the market and how many farms are technically economically viable by our definition. So this is results by gross output on an annual basis. So I'm highlighting annual there because I'm going to show the 3-year average as well. This is by hectare by farm system, and you'll see there when I say about the volatility, this is classic volatility here, where we very high output year in 2022, very challenging year in 2023, but recovery in 2024. And we're seeing a similar trend when it came to gross margin on an annual basis. High gross margin in terms of the historic trend in 2022, challenging year 23, and recovery in 2024. But when we look at the 3-year average, where that volatility is kind of smoothed out by the 3-year rolling average. When I say 3-year rolling average, I mean 2024 would be the average of 24, 23, and 22. And if you look at the output per hectare, you'll see the long-term trend across all farm systems is upward in terms of gross output and in terms of gross margin. And dairying, especially on the upward trend since about 2018. So moving on to the labour element. So again, on an annual basis, we're looking at returns to unpaid family labour. So again, we're seeing this volatility. We had record levels of returns to labour in 2022 across especially tillage and dairying. Again, very challenging 2023, but recovery in 2024. And that was mirrored in terms of the family farm income per hectare, where you had the exact same profile of results as they had for the unpaid labour. But we should note that, okay, although 2024 is not as high as 2022, if you take in 2022 out of the long-term time trend, 2024 would be the second highest since we've been doing this kind of analysis. If I look at that over the 3-year average, again trying to account for the price and weather volatility, the long-term trend is increasing, is upwards in terms of returns to labour, unpaid labour, and for family farm income, except on the tillage side, which seems to have flatlined or slightly decreasing at the end of the time period. Just want to say that all of the results I've presented so far and will going forward looks at averages, but there are significant heterogeneity we've already seen across systems, but also within systems. So this is a dairy, cattle, and sheep and tillage. You can see the legend and the y-axis is different, but as you can see between the significant variation within system as well as across system based on top, middle, and bottom by economic performance. Final economic one I want to mention is economic viability. What's the definition? Well, can the farm achieve the minimum wage, which in 2024 was $12.70, plus give a 5% return on non-land-based assets? It's a binary yes, no. Can it meet this achievement? This barrier? Again, looking at it on an annual basis first, we're seeing again mirrors what we've seen before. 23 up, 2022 up, challenging 23 and recovering 2024. On the 3-year average, again, you're seeing a bit of a smoothing story. Dairying is pretty static, tillage slightly declining, and actually in 2024 for the cattle and sheep systems, we saw a record level of, although it's quite low, it was the highest level of economic viability we've seen across the time series. Okay, so moving on to the second dimension is the social sustainability. So again, this is when you click into our sustainability dashboard, this is what you're going to see. We've done it slightly differently this time in terms of we've grouped some of the indicators that don't tend to change a whole lot from year to year in kind of a dial gauge type presentation. And then the time series we presented for gross and net protein and hours worked. I'm not going to present results for gross and net protein because Maria has very eloquently done that in the previous presentation. But I will get into a little bit in terms of the trends around hours worked across the different farm systems. So I mentioned that some of the traditional ones we report on the social sustainability, these ones don't tend to change a whole pile from year to year. So we kind of looked at presenting them in a dial format. They are presented across all the farm systems across the years. So you can flick through to have a look to see if you want to see what's happening, but they don't tend to change a whole pile from year to year, given the nature of the metric. Final one I want to look at on the social side is hours worked. So again, I'm just giving the 3-year average in this case. So the first one is hours worked on the farm. The second one is hours worked on and off farm. And the final graph then is the percentage of hours worked on the farm versus total. So how many of all the hours worked, what percentage is worked on the farm. First thing to notice is there's a significant gap between the dairy farm operator and the non-dairy farm operators in terms of hours worked both on farm and off farm. And a slightly worrying trend is that this trend has been upward for dairy farms since quota abolition. We've seen the dairy farm operators are putting in more and more hours on an annual basis. The non-dairy farms are actually decreasing their hours on farm, increasing them off farm, so their portion of the total hours worked on farm is actually declining as they substitute away from on farm to off farm. Okay, so the third leg of the stool is the environmental sustainability, and a bit more busier. This is what you see when you log into the dashboard. It's a bit busier than the social and the economic because of a lot more indicators in this dimension. So we have greenhouse gases, ammonia, and nutrient use efficiency, which is relevance for water quality, all other things being equal. In terms of greenhouse gases, we're reporting on agricultural greenhouse gases and energy. When I say energy, it's the minor element, but it's mainly related to electricity and fuel and that kind of thing. Across the gaseous emissions dimensions, GHG and ammonia, we're reporting on a per hectare and per farm basis and per kg of output, main output produced milk, beef and sheep, and euro of output. And on the nutrient use efficiency, we're looking at balances and use efficiencies. So looking at the farm level in terms of decomposition, 601 tons total were generated on average on dairy farms in 24. Majority of it related to milk production, but you also had a smaller component related to cattle, mainly related to rearing of replacement heifers and also cull cows and calves sold, etc. This is about 4.5 to 5 times higher than the non-dairy farm emissions, due to the nature and intensity of production. Just to note that even though they're classified as sheep and tillage, and I noted this earlier on, a lot of the emissions are actually coming from the cattle enterprise. The majority in the case of tillage farms are actually coming from a cattle enterprise on the farm. What's happening on an annual basis in terms of the time trend? So if you look at it on a total farm basis, we're looking at a total farm basis and on a per hectare basis. So again, a significant difference, a gap between what's happening on dairy farms and non-dairy farms. Less so, the gap is less pronounced on a per hectare basis because dairy farmers have larger farms in general versus cattle farms and sheep farms. Non-dairy farms, the trend is downward and on an annual basis and on a per hectare basis, both farm and per hectare. On a farm basis for dairying, it's kind of flatlined in the last few years, and it's decreased on a per hectare basis because the farm size has actually been increasing on dairy farms. Same graph, but if I do it over the 3-year average, you're seeing the declining trend is crystallized here in the non-dairy farms on a per farm and a per hectare basis. The dairy farms are looking to about they're plateauing or just they're slightly increasing, but about the plateau on the time series, and they have plateaued and declining on a per hectare basis. We also produce some results on carbon footprint of the main product. So in the case, this is just presenting on the 3-year average here. So the graph on the left is the carbon footprint of milk on an IPCC basis, both at actually kgs of milk and corrected for fat and protein. So it's fat and protein corrected, which is 4% fat, 3.3% protein, standardized kg of milk. So you can see on the carbon footprint of milk, generally since about 2017, or all the time series, the trend has been declining. Output tends to be increasing per cow and so on. On the livestock side, we have the carbon footprint per live weight beef and sheep over the 3-year average, and over through time series again, we're showing a declining trend again, which is positive in terms of the carbon footprint on a kg of product basis. This is something new which we have included in the dashboard this time for the first time. It hasn't been presented in the report before. It's emissions by source. So again, I'm just using the annual for an example, and I'm using the dairy farm system as an example. So we're replicating what's generated in the national inventory reports in terms of the categories, so enteric fermentation, manure management, agricultural soils, urea application, and liming. And again, I want to draw attention to the scales on each of these are different. So enteric fermentation is the majority, followed by ag soils and manure management. Urea is less than 1%, and liming less than 3%. In terms of the trend, then you can see on the annual basis, because since quota abolition, herd sizes have tended to be increasing, the enteric fermentation part has tended to increase. Whereas on the ag soils category, there's been a reduction in chemical end usage, so that category of emissions has declined. Whereas as people substitute away from canned protected urea, which releases CO2 directly, there's been a slight increase. There's been an increase, but it's small in the overall scheme of things in terms of the urea application. So this is there for benchmarking and to try to disaggregate what's happening in individual farm systems. Okay, so moving on to ammonia, it's quite a similar story to greenhouse gases, to be honest. We have the annual result by farm and by per hectare basis. So again, we're seeing big gaps between dairy and non-dairy systems, both on a per farm and a per hectare basis. The per hectare is less pronounced, again, as dairy farms are larger. The trend, again, is downward for the non-dairy systems and for the per farm and per hectare. A little bit jumpy in terms of the annual for the dairy system on a farm basis, but declining on a per hectare basis. This is kind of becomes clear when we look at the 3-year average, I guess. The non-dairy systems crystallize and definitely showing a declining trend. The dairy farms on a farm basis have kind of plateaued and are declining on a per hectare basis. Okay, so the final indicator on the environmental side I'm going to mention is nitrogen use efficiency. So first of all, we have on an annual basis, we have the N balance per hectare, what is this made up of? Basically, you're trying to track what comes into the farm and inputs and feed and fertilizer, and what goes out in product, meat and milk. And one minus the other gives you your surplus or your deficit. So again, we're seeing large gap between dairy and non-dairy systems. But generally speaking, the trend has been a downward trend. And use efficiency is kind of agronomic efficiency measure, how much N is going out in product. So tillage systems tend to be the most efficient because the nitrogen is not cycling to an animal. But if I do that on the 3-year average, we're seeing that the declining trend is crystallized both on the dairy and non-dairy systems. There was a slight increase in 2024 due to slightly higher in fertilizer rates and concentrates, but the long-term trend has been down. And in terms of use efficiency, the long-term trend has been improving, or greater use of the nitrogen within the system to generate product. Okay, so the last couple of slides then, in terms of innovation indicators, I'm looking at 2. This is a low emission slurry spreading. And we've seen a significant increase in this in the last couple of years. So in dairy farms in 2024, 85% of all slurry was applied by a low emission slurry spreading, and 45% of cattle farms was applied by low emission slurry spreading. So it came from a very low base around 2015, 2016 when it kind of kicked in. Second one I'm going to mention is protected urea. We're seeing a significant increase, especially on dairy farms. 40% of all chemical N applied in 2024 was in the form of protected urea. Less so on cattle farms, 14% and 9% on sheep farms. But it's a lower level, but it's definitely increasing. You can see there it almost doubled and trebled from the previous year. So the direction of travel is in the right direction. Okay, finishing up then, in terms of just, I suppose, to focus on the 2024 story, with a strong recovery on dairy and dry stock farms versus 2023, which is a very challenging year. Village farms also recovered, but not to the same extent. Dairy farms are still performing better economically and socially in terms of social metrics than other farms. Quite strong on the social side, except for the hours worked, which is a bit concerning, that the number of hours being put in by the main farm operator are increasing incrementally. I'd say on the back of stronger economic performance, we saw lower levels of household vulnerability across all systems. We saw kind of period high economic viability for cattle and sheep farms. In terms of GHG and ammonia for 2024, the absolute emissions tended to be declined across all farm systems on a farm basis and mostly on a per hectare basis. On the 2024, we saw kind of the carbon footprint of ammonia and GHGs for milk fairly static. Beef declined and sheep increased slightly. The N surpluses saw a slight increase on the previous years across all the dairy, cattle and sheep farms, again based on slightly higher chemical N and concentrate use. Tillage farm surpluses declined. Some very positive signs in terms of low emission slurry spreading and protected urea use. So finally, I want to acknowledge some people before I finish up. To echo what the director said, I really want to acknowledge the farmers who participated in the National Farm Survey, without whose participation we wouldn't be here today. These recorders who do a fantastic job in collecting the data and who haven't been found wanting when we've asked to collect different types of data on the environmental side. Brian Moore and Donnellan for the data validation. Maria Merlo for generating the new protein indicator. And special award to Sofia Tisocco for the Trojan work, who was the driving force behind this, generating the sustainability dashboard. So that's my email address for anyone who's follow-up queries. And there's a link to the report itself. And the second one is linked to the sustainability dashboard. So that's me.
Thanks a million, Cathal. That was really good, very comprehensive as always. And I might invite our colleagues to turn back on their cameras. Webinar attendees have been putting questions into the Q&A, and I haven't been banging on about doing that, but there's a number of questions in there, and we'd welcome some more. We've got about 20 minutes or so, 25 minutes maybe, to talk about the issues we've discussed here so far in the various presentations. So we've got about 10 questions, and the first question that I'm going to turn to, in terms of its in the screen in front of me, is about the ability to talk using the National Farm Survey at different geographical scales. Trevor, do you want to take that question? can data be attributed to county or any other geographical area is what the person's asking.
Yeah. The answer to that question is it depends on how small the region is. We have some regionalized analysis in the National Farm Survey, but what you need to understand ultimately is we have 900 farms representing 88,000 farms in the actual population. So if you decide to focus in on a region, you're focusing in on a smaller number of farms in the population, but you also have a smaller number of farms in the sample available to work with as a result. And one of the issues we have, I suppose, is that agriculture has a degree of heterogeneity in it. Not every farm is the same as the next farm. And as your sample gets smaller, it becomes harder then for the sample to represent the population within that particular region. So long story short is if you wanted to have the capacity to be able to talk about these kind of things at a county level, and bearing in mind our counties are quite different sizes, particularly in terms of the level of agricultural activity, you would need a bigger sample to be able to do it in a way that would be statistically rigorous. In other words, the confidence interval, going into technical details, the confidence interval, or the level of confidence, I should say, that we have in our results would be lower when we go down to especially if we were to go down to quite small regions like counties.
And I guess, Trevor, there's a series of other questions about whether the data can be brought back to individual level and why the big emphasis on confidentiality of data that we've always maintained. I mean, some of that's legal requirements in terms of what we have always promised farmers in terms of the data we collect. But I presume the reasons in terms of why we can't talk about individual farms are mostly because, like, what does that mean? Even if we were allowed to do it, what would we be able to say about what it means if we did?
Yeah, I mean, we don't publish data on individual farms. That's not what the National Farm Survey or its parent, the Farm Accountancy Data Network in Europe, is about. This is not a policing tool. The National Farm Survey is about collecting accurate information on what is actually really happening on farms. We have a GDPR regulation, a general data protection regulation, which means that data can only be used for the purposes for which it was given, number one, and farmers who participate in the National Farm Survey provide their data unless otherwise stated to be able to produce aggregate results, not results on individual farms. And even aside from that, before the general data protection regulation existed, there's been a long-standing agreement with farmers over the 50 odd years that the National Farm Survey has been in existence that their data is provided on a confidential basis unless any individual farmer were to choose to waive that confidentiality. So yeah, we're not in the business of producing or publishing results on individual farms, and even we have thresholds whereby in terms of aggregations of farms, we won't, once the number of farms is too small, we won't actually publish even for a group of farms. Which goes back to the issue as well in terms of the challenges around publishing data for small regions. Okay.
Yeah. They're related to one another clearly. Frank Convery, our colleague from UCD, Professor Convery, kind of as usual, is effusive in his praise about thanking everybody for the work they do on this. But he's got a question about fertilizer data by region, which you have, and he's wondering, is it possible to look at these data at a catchment scale or sub-catchment scale, given that that's the unit of physical processes that matters for some elements of water quality? Cathal, do you want to answer that, or Trevor, or Donnellan?
Yeah, I'll have a go. I suppose we have a kind of following from Trevor's point, would have a challenge at a catchment scale from using the NFS data because of the representativity of we have enough farms in each catchment to make it representative. I doubt we have, but if we could get the NFS talking to things like the AIMS and the LIPUS and stuff like that, we could probably simulate a population of farms need catchments, and the Fertiliser Use Survey, for example, would, the fertilizer register, if and when it becomes I suppose if it becomes available, or and people believe it's robust, that could potentially be used. But there are ways the different ways to skin a cat, but I don't think the NFS is the vehicle to have representativity at a catchment scale. But I do take the point.
And then a quick follow-on from Frank was relating to the comparability of our footprint indicators with those that the Research Centre have published. I presume the emission factors are the same. Possibly this question is about where the boundary is set in terms of the life cycle analysis of that footprint. Do you want to comment on that?
I'd have to get in to see what the boundaries are, but we've used the IPCC boundary. We do have an LCA for dairy, and we have been trying to get an LCA for beef and sheep, but we haven't given up on it. Hopefully might do it in the next year or two, to have both. But we tend to operate it at the IPCC boundary. But I'm not even sure, like through FSDN, that kind of comparison is available yet. Trevor might be able to comment a bit more on that.
Well, I think it's going to be quite limited in the end, really, in terms of what FSDN might be capable of doing in terms of an LCA, because ultimately, in the end, you can make an LCA is as long as a piece of string in some sense, depending on where you decide the boundaries are. But once you start moving off farm, you're starting to get into areas that are unrelated to, I guess, primary agriculture, which is what the core of what we're doing is. And as a result of that, you're starting to create demands for data that may not exist, basically. So I think it's somewhat challenging to do an effective LCA in a consistent way, where you move too far beyond the farm level. That would be my take on it.
Okay, Mary, a question for you on protein, and I know you answered it directly to the questioner in the chat, but just for the wider audience, this question was about whether or not those indicators of gross and net protein per hectare include pig and poultry output. And do you want to just for the benefit of those who didn't ask the question, what the answer to that one was?
Yeah, so no, they're not. So we only consider land-based systems, so beef, so cattle, dairy, sheep, and tillage systems. So indoor systems are not considered. The analysis is kept to the land-based production. There would be something to look at in terms of those systems, pigs and poultry, but they're not included in this analysis in particular.
Okay. But conceptually, if we had the data, we could look at it, right, in terms of the
balance. If we had the data, the same exact methodology could be applied. It's just a matter of getting data from those production systems. Yeah.
Okay. A question about tillage farmers and the definition of specialist tillage farmers. Trevor, I know you've answered this directly to Siobhan Walsh, who asked that question. Do you want to share the answer in terms of who is represented and what they represent?
Yeah, I mean, we're following typology definitions that are set up by the European Commission. I mean, in the end, we hear about the National Farm Survey in Ireland. We don't hear, I suppose, as much about the comparable surveys that are taking place in other countries, but they do exist. And to ensure consistency of approach, there are definitions around all of these farm typologies. So we're using the definition we have for tillage farms, which is basically a definition borrowed from the Farm Accountancy Data Network, or the Farm Sustainability Data Network, as it's now called. I can understand that some people have a particular view as to what they consider to be a specialist tillage farm in terms of the percentage of the activity on the farm that is tillage. But like the reality of tillage farming in Ireland is that many of the farms that are mainly tillage farms have a secondary activity taking place on those farms.
And so, like in the European topology, you're a specialist tillage farmer if you're a standard output from your farm. Two-thirds or more of that is tillage crops. So the ones we report as tillage farms in Ireland are in that set of farms that are similarly classified. Thanks, Trevor. There's a question here from Eduardo Baldoni from the Joint Research Centre, and it's about presenting output values and GVA and so on in nominal or real terms. And I guess all our numbers are in nominal. But it might be interesting to think about how they look different or look the same if we deflated them by a measure of consumer prices or some other inflation measure. Open questions that have been coming in. You think question about
there on biodiversity. I might just pick it up.
Shoot on.
Yeah, I've been saying for about 5 years now that we're hoping to add a biodiversity indicator, and I think we're almost there. We have a proof of concept. We know how to do it. We're just having problems with getting access to data on our NFS farms. So there's two things we're trying to link it to the land use survey published by the Urban Survey. Hopefully that will be repeated in time so we can track changes through time. So the answer is, Celine, I think, asked the question. We hopefully we will have it very soon. It's not any technical difficulties. It's access to data difficulties we've come across.
Okay. Question from an anonymous attendee about social indicators, and I know that we have ongoing research in terms of expanding the set of indicators related to the social dimensions of sustainability. Do you want to give a teaser answer to that, Cathal, in terms of or Trevor, about what's going on or what's in the hopper?
Yeah. Look, our colleague Emma Dillon has a very active research program on this, and she's going to be working with a few people who are going to be hired to develop these indicators through the AgNav platform. So, look, we will do a comprehensive trial again to see what we can include from the data we have to add value on the social side.
It's a technical question for you, Cathal, on the agricultural emissions from soils. I'm wondering whether those emissions are computed at tier 1 or tier 2 values. And I guess that reflects what's used in the Irish inventory, I presume, in terms of how we do the numbers.
I think, depending which category of agricultural soils, I think it's a combination of tier 1 and tier 2, mainly tier 2, to be honest.
Yeah. Okay. So, but I did mean, generally speaking, each year we aligned with what the EPA have in terms of the published inventory methods that they're using.
Yeah, that goes to another question asked there, Kevin. We basically replicate what the EPA do. When they move, we move.
Yeah. A question from Philip O'Brien, wondering whether the income analysis that we produce in the farm survey includes diversified activities such as forestry on the farm or something else. I guess other gainful activity is the jargon phrase that's used in terms of what goes into the FSDN, which, if it is the other gainful activity or a forestry income, that's in family farm income. Isn't that correct? I think it is. So,
yeah, I think we'd have to check on that one, Kevin, to be honest. I mean, there are specific categories of income that are beyond the traditional definition of agricultural farm income that we do collect, but I would have to go back and check in terms of our own farm income figures what is and isn't excluded in that definition. But we do collect the data on other activities happening on the farm, but they can fall into other income categories ultimately from the point of view of reporting them to the European Commission.
Okay. The question about the number of farms that we have and how long these farms are providing data to us through the National Farm Survey. That's an interesting question. I guess, Trevor, some of our farms have been in our sample for quite a while, and sometimes that's a great thing because we can look at how things develop longitudinally, but there is some turnover. Do you want to comment on that question or answer it?
Yeah, I suppose it depends on what you're trying to do here. I mean, we're trying to use the National Farm Survey for two purposes. We're trying to track what's going on from an economic, environmental, and social point of view on the one hand, and we're also trying to create a resource for research purposes. Like if you took the extreme case and every farmer stayed in until they basically retired or died, we'd end up with some curious things happening in the survey, like that the age of farmers was drifting up at a very predictable rate, for example, because every farmer in the survey would be a year older. So there is a degree of dropout from the survey, and it varies from year to year. It's not consistent. When farms leave the survey, they're replaced. So we're generally trying to replace the farms with a farm that's similar in terms of its agricultural activity or the size of the farm, because we have specific criteria we need to fulfill in terms of a matrix, for want of a better word, of farm types by farm sizes that we're trying to keep to. So yeah, there is turnover in the farm population, but if there was a very high turnover rate of farms in the National Farm Survey, the survey would become less useful then in terms of tracking the performance of individual farms over time, which can be important depending on the type of research question you're looking at.
Question for you, Marie, on Lady Céline Delebre, welcoming the addition of protein production in terms of an indicator, which is great. She's asking, what was your biggest surprise in terms of analyzing these data? She says, maybe it's difficult to judge if this is the first year, but did you have any kind of a priori expectations that weren't kind of confirmed by your analysis, or would you like to comment or care to comment on that?
Yeah, I guess a bit of a surprise when it came to the difference between dairy and tillage farm on one side and sheep and cattle farm on the other. Yeah, didn't expect the gap to be that wide. That makes sense. It is due to a lot of structural characteristics of the different systems that make sense if you look a bit deeper into it, but having that aspect was a bit surprising. The digestibility component as well was very interesting to include in the analysis because it does matter in terms of the results you get. And a good surprise, if I can say, would be the extent of the contribution of the Irish agricultural sector, or the land-based systems, to be more precise, given the previous question. But yeah, comparing the Irish population versus the number of individuals who can be fed in terms of protein by the aggregate land-based systems was a nice surprise in terms of the global contribution of agriculture, of the Irish agricultural sector. So yeah, it'd be interesting as well to follow in the next years to have to see the time series and see what's happening in the next few years in terms of output. Yeah.
Yeah, I agree. This is the sort of the mirror of the challenge we have in terms of our emissions, and that we have the load of emissions from agriculture in Ireland, relatively speaking, but greenhouse gas emissions. But we do produce an awful lot of protein to go with those emissions that are demanded by the world out there. We're almost running out of time. There's a question from our colleague Laura Boyle in Moore Park about, are we considering incorporating indicators of animal welfare possibly in our social sustainability indicators? And that's a really interesting question, and it's something I think we can take away and chew on in terms of the data that we'd need to do that. But thanks, Laura, for that question. And the final question, and there may be other ones that have come in, is from Julian Worley, asking, given that farm viability is defined relative to family labour use and capital returns, how do unpaid labour adjustments alter our understanding of economic sustainability across farm systems? And I guess that's so we express it as the family farm income per annual work unit that's the family is supplying, given that the paid labor is already counted in the direct costs of production that the farmer has. So Trevor, I'm not sure if I'm missing anything there, but I think we try to account for the fact that we express our income outcomes per family labor unit as opposed to total labor units used on the farm. You're
Never faced attempting to answer that question than you have, Kevin. I think I'll leave it as is.
Well, I just might add that, like, you saw that the dairy farmers are putting in an awful lot of labor compared to other systems, and there's more family labor going into dairy systems. So when you look at it, if you compare it per hectare and per farm, the gap isn't as wide between the non-dairy systems when you count for all the labor that's going in.
Yeah, so we've 130,000 euros per farm, but we've got close to 2 or maybe a little more than 2 family labor units actually being supplied. So per family labor unit, the gap between what the typical dairy farm is earning converges somewhat to the other farming systems, but it's still greater per labour unit supplied by family farms, I understand. So listen, guys, can I thank on behalf of all the seminar attendees, all of my colleagues from the Agricultural and Farm Service Department for our series of really great presentations, and can I thank Teagasc's Director Frank O'Mara for attending the seminar and for support of this kind of research agenda and all the work that we do within the National Farm Survey. And finally, can I thank you, the audience, for your great questions and for attending. And again, to reiterate the point made by everybody, thank the farmers out there who supply us with the data that allow us to provide this analysis back to them and to you and to the wider society. So thanks a million and have a good day.